Chapter 2: The Atom, Seeing the Invisible. Let us begin with the most fundamental entity in physical science, the atom. The word comes from the ancient Greek atomos, meaning indivisible, uncuttable. The philosopher Democritus proposed the concept around 400 BC, that if you could keep dividing matter into smaller and smaller pieces, you would eventually reach a point where you could divide no further. That indivisible unit he called the atom. For over 2,000 years, the atom was a philosophical idea. No one had seen one. No one could see one. There was no instrument capable of detecting something so small. The atom was real only as an inference, a logical necessity that explained why matter behaved the way it did. In 1803, the English chemist John Dalton proposed the first scientific atomic theory, not from direct observation, but from the ratios in which chemicals combined. He inferred the existence of atoms from patterns in chemical reactions. He had still never seen one. In 1905, Albert Einstein published a paper on Brownian motion, the random jiggling of small particles suspended in a liquid, that provided the first indirect experimental evidence that atoms were real. He had still never seen one. In 1911, Ernest Rutherford fired alpha particles at gold foil and inferred from the way some bounced back that atoms had a tiny, dense nucleus. He had still never seen one. In 1913, Niels Bohr proposed the quantum model of the atom, electrons orbiting a nucleus in specific energy levels. He had still never seen one. All of this science, all the periodic table, all of chemistry, all of nuclear physics, all of the technology built on these foundations, was built on the confident knowledge of entities that could not be seen. In 1981, Gerd Binnig and Heinrich Rohrer built the first scanning tunneling microscope at IBM's Zurich laboratory. For the first time in human history, individual atoms became visible. They won the Nobel Prize in Physics in 1986. 2,380 years after Democritus proposed the atom as a philosophical idea, human beings finally saw one. For all of that time, all 2,380 years, atomic theory was the substance of things hoped for, the evidence of things not seen. And it goes deeper. The electron, the particle that makes chemistry, electricity, and every digital device in the world possible, is not a tiny ball. It is a quantum object. In quantum mechanics, an electron does not have a definite position until it is measured. Before measurement, it exists as a wave function, a mathematical description of all the possible states it could be in and the probability of finding it in each. The act of observation collapses the wave function into a single definite state. This is not a limitation of our instruments. It is the fundamental nature of reality at the quantum level. Werner Heisenberg's uncertainty principle, established in 1927, states that the more precisely you know the position of a particle, the less precisely you can know its momentum, and vice versa. This is not because our instruments disturb the particle. It is because position and momentum are not simultaneously definite properties of a quantum object. The universe, at its most fundamental level, does not consist of objects with definite properties that we cannot quite see. It consists of objects whose properties are only definite in the act of measurement. At the deepest level of physical reality, the world is not made of things. It is made of potentialities, mathematical structures that become real through interaction. The physicist Max Planck, who founded quantum theory, wrote near the end of his life, "As a man who has devoted his whole life to the most clear-headed science, to the study of matter, I can tell you as a result of my research about atoms this much: there is no matter as such. All matter originates and exists only by virtue of a force which brings the particle of an atom to vibration and holds this most minute solar system of the atom together. We must assume behind this force the existence of a conscious and intelligent mind. This mind is the matrix of all matter." The founder of quantum theory concluded that behind the invisible fabric of physical reality is a mind. The ancient letter to the Hebrews said that the invisible is more fundamental than the visible. Modern physics agrees.